Hey, what's up everyone? Vegetarian Zombie here. Welcome back to another episode on Beginning C# with Unity. In this episode, we're going to review abstract classes. Abstract classes is another tool in our toolbox for designing our code. They allow us to get abstract, so to speak. But before we dive in, as mentioned, my name is Vegetarian Zombie. I run this YouTube channel as well as Jesner.com. If you enjoy these videos and you want to see more, feel free to subscribe to this YouTube channel. Basically, thank you for being here. I hope these videos help you. A few episodes ago, you built a dinosaur class and later created a T-Rex subclass. At the time, I mentioned that a dinosaur class didn't really make sense. There's no actual dinosaur. That's really just a categorization of subsequent dinosaurs. There are times like these when you design classes that aren't meant to be instanced. These are known as abstract classes. They look and behave like normal classes, except they are marked with the abstract keyword. When you have an abstract class, you can't instance it. You'll get an error. These are designed specifically to be subclass. Let's take an example of a drawing app. Let's say you want to draw shapes to the screen, so you might define an abstract class called shape. This class will contain a property that has a total number of sides. You might also create a draw method. Now, if I create a triangle class, it will inherit everything just like any other class. But there is a problem. What if I want to draw a circle? That's a shape, but it requires different drawing calls than a figure composed of lines. In fact, it's best for each shape to manage their own drawing code. Yet, you want that draw method to be part of every shape subclass. You can't expect people to opt in. People will forget. It's best for the compiler to enforce the requirement. For this, you can also designate methods as abstract. For abstract methods, you just provide the method header annotated with the abstract keyword. You do not need to provide an implementation. Now, every subclass will need to write that method body. One thing to keep in mind, abstract methods can only exist on abstract classes. Let's see these in action. Okay, here we are in Visual Studio Code, and I have my dinosaur class open. Like mentioned, the dinosaur class doesn't really make sense. I never intend to create an instance of it. It was only designed to be subclassed. This is a perfect example of an abstract class. First, add the abstract keyword before the class name. And look at that, you have your first abstract class. Now you can no longer create a dinosaur class. Open my objects and in show message, add the following. You'll see we get an error. This is great. We get compile time checking. Let's delete this code and go back to our dinosaur. Now let's update the roar method. This should really be dino specific. Change the method to the following. Now every subclass will need to provide its own roar. This does cause an issue with Rexy since that subclass is using code that we just deleted. Change the method to the following. Notice we still had to override the method. Now switch over to my objects. Add the following in show message. Save, switch back to Unity, run the game. Press the button. We get a roar. If you are confused, that's okay. When I first started programming, I wrestled with this for a while myself. For the record, you did not create a new dinosaur. Remember, you can't do that. You created a T-Rex object, but the T-Rex object has a dinosaur interface. We're going to spend the next 2 episodes covering this, so buckle up and hang on. In the next episode, you'll learn about an interface, and then you get a deep dive of polymorphism. These are just fancy words that illustrate the versatility of objects. This is also what makes object-oriented programming so popular. See you in the next episode.